You're welcome, our dear student, in this new episode from your program مدرسة على الهواء. Today, let's go on completing what we started before about properties of matter. We talked about the physical properties of matter, and now we're gonna talk about the chemical properties of matter. We're gonna talk about metals and chemical activity. As we know, we have a lot of metals. We have a lot of metals. We have some metals that have a very, very strong activity, chemical activity, and another metals that are weak in chemical activity. So we can classify metals according to their chemical activity into three parts. Number one, very active metals. What's meant by very active metals? Very active metals, they are metals that react with oxygen in presence of humid air and lose their luster. As you know, my dear student, that as we studied in primary 4, that metals are or have metallic luster. Metals have metallic luster. But now we study that very active metals, they are the metals that react with oxygen in presence of humid air and lose their luster. Lose their luster because they form metal oxide. Metal oxide. As what? As sodium and potassium. So we can't leave sodium and potassium in free air, in atmosphere. Why? Because they are very active metal. They react with oxygen and lose their luster and their damage. Sodium will be sodium oxide, not sodium. Potassium will be potassium oxide, not potassium. So we have to find way, we have to find method to keep sodium and potassium from reacting with oxygen. So we keep them under the surface of kerosene. And there is a question that says, give reason for sodium and potassium are kept under the surface of kerosene. Why? Because they are very active metals. And now, number 2, less active metals. From the title, they are the metals that react with oxygen after some days and rust. Not quickly, not in short period of time, but they need time to react with the oxygen after few days and rust. Like what? Like iron and copper. So it's a problem that we face when we leave iron in air. Iron will react with oxygen of air after some days and form a layer, brown plated layer that is called iron oxide, and it causes damage of iron. So we can't leave iron in atmosphere without covering it. But how can we cover iron? We can cover iron by plating it, by covering it, by painting it with nickel, with silver layer to protect it from reacting with oxygen, to protect iron from rust. So sometimes we see lamp posts on the roads are painted with what? With silver or with nickel layer. Why? To protect iron from rust, from reacting with oxygen. And this is another question, give reason for. Cooking pots are washed with a rough material. As we know, cooking pots are made of aluminum. And from time to time, mother wash these plates, wash these pots, wash these pans, wash plates, or cooking pots with a rough material. Why? To remove the rust layer. To remove the rust layer. And number 3, as we classify metals, number 3, inactive metals. What's meant by inactive metals? They are metals that face great difficulty, find great difficulty in reaction with oxygen. Not easily, but under some special conditions they can react with oxygen. So they are very expensive, like silver, platinum, gold, nickel, and chromium. So, as you see, my dear student, metals are classified according to their chemical activity into three types. Number one, very active metals, potassium and sodium. Less active metals, iron, copper, and inactive metals. But now, let's go to study the lesson number 2. Lesson 2. But before lesson 2, give reason 4. Lampposts are painted with layer of nickel to prevent rust, as it is inactive metal. As nickel is inactive metal. Unit 1, lesson 2, matter construction. Matter construction. Any matter, any element, any substance consists of small particles that are called molecules. And the molecule, as we will study after time, consists of atoms. But what is meant by molecule? As we see on the monitor, the molecule, it is the smallest part of matter which can exist freely and has the properties of matter. What does it mean? If I have sugar, a block of sugar, this block of sugar, can I make it powder? First part, the smallest part of powder of sugar is called molecule, because it has the color of sugar, taste of sugar, and it can exist freely. There is another smaller particle of matter called atom, but the difference between atom and the molecule, that molecule can be existed freely, while atom can't be existed freely. Why? We will know next time. But now, what's meant by molecule? Molecule is the smallest part of matter which can exist freely, and it has the properties of matter, the color of matter, the smell of matter, and all properties of matter. Now the question, give reason for, if you spray some perfume, you can smell it all over the room. All of us have these notes. When you spray some perfume, you can smell it all over the room. What does it mean? It means that perfume, as any matter, consists of small particles that are called molecules that spread all over the room. So you can smell these molecules and feel that perfume is spread in all the room. This is a provement for what? For that the matter consists of molecules. The molecules of matter are in, this is number 1, first property, properties of molecule. We know that matter consists of molecules. But what are the properties of molecules? Number 1, molecule of matter, all molecules of matter are in states of continuous motion. So now there is a give reason for what water changes violet when you put a drop of potassium permanganate in it. Potassium permanganate has violet color. When we put just a drop of potassium permanganate or just a drop of ink, blue ink maybe, in a cup or in a glass of water, after time all water changes to give the same color of this drop that you put in. If it is potassium permanganate, you will get violet color. If you put a blue drop of ink, you will get blue color. Why? This is the color of potassium permanganate, violet, because molecules of matter are in a state of continuous motion. As you know, my dear students, we have 3 states of matter: solid, liquid, and gaseous state. all these states of matter consist of what? Consist of molecules. We have water. Water in solid state is called ice. We have water in liquid state is called water. Gaseous state of water is called water vapor. But all these states of water consist of what? Of molecules. Okay? In solid state of water, ice, the molecules of water are in a state of continuous motion. They move continually. But the motion here in solid substance are limited. The motion is very limited. Okay? But the motion in case of gaseous state as water vapor is very, very high. So, number one, the molecules of matter in a state of continuous motion. Number two, there are intermolecular spaces between molecules. Intermolecular spaces between molecules. Okay. What's meant by intermolecular spaces? It means spaces between what? Between molecules. So, intermolecular spaces mean what? The spaces among the molecules of matter. As you see here, my dear students, each state of matter has molecules, consists of molecules. These are molecules of matter, and these are molecules of another state of the same matter. This is solid, but these molecules of liquid. And for gas, they are separated, they are far away from each other. Gas. These molecules are in a state of continuous motion. They move. And there is limited spaces between them. And these molecules of liquid state in a liquid state of matter also have what? Intermolecular spaces. These spaces are called intermolecular spaces. They are spaces between molecules of matter. And these molecules are also in a state of continuous motion. They move. And also in gaseous molecule. Now we talked about what? About the molecules of matter in a state of continuous motion. Number two, the molecules of matter have spaces between them are called what? Intermolecular spaces. Now the question, as you see on the monitor, give reason for when you add 200 cubic centimeter of ethyl alcohol to 300 cubic centimeter of water, the volume of the produced mixture is less than 500 cubic centimeter. This is a question. So, if I put 200 cubic centimeter of water in a graduated cylinder that contains 300 cubic centimeter of first one of ethyl alcohol, number two, water. It's supposed that the volume of produced mixture is what? Is 500. But in fact, if you add 200 cubic centimeter of alcohol to 300 cubic centimeter of water, the produced mixture is less than 500. I think it will be 480 cubic centimeter. Now the question is why? The question is why? Where is the 20 remain cubic centimeter? The answer will be like that. These are the molecules of water, 300 cubic centimeter. when we put ethyl alcohol, some molecules of ethyl alcohol go to fill the intermolecular spaces, the spaces between molecules of water. So this amount will not appear as increasing in volume of the produced mixture. We can't feel increasing here, but after filling all intermolecular spaces of water, now we can see the increasing in volume of the mixture. So the answer will be what? Will be because molecules of alcohol fills the intermolecular spaces of water first. Number 3, there are intermolecular forces between molecules. The properties of molecules: number 1, molecules are in a state of continuous motion. Number 2, there are intermolecular spaces between molecules. Number 3, there are intermolecular forces between the molecules. What is meant by intermolecular forces? As you see, my dear student, this whiteboard is solid. If I wanted to cut it, to break it, it's not easily. Why? Because there is a strong force that binds these particles together. Does it consist of particles? Does it have molecules? Yes, because it is matter. Any matter consists of molecules. But these molecules are close together, and there is a strong intermolecular force between their molecules, or its molecules. What does it mean by, or what's meant by the intermolecular forces? As you see, my dear student, intermolecular force means the force that binds the molecules of matter together. As you see on the monitor, intermolecular force, it is the force that binds the molecules of matter together. As you see here, molecules of solid are close together. Now, as I told you before, we have solid state, liquid state, and gaseous state, or gas. What's the difference between solid, liquid, and gas? Solid state consists of molecules, and these molecules are close together. Liquid state consists of molecules that are not close together as in the solid state. And in gaseous state, the molecules are very far away each other. But we talked about 3 properties of molecules. Number 1, the molecules of matter are in a state of continuous motion. But do molecules of solid in a state, or are they in a state of continuous motion or not? Yes, they move. Can you notice, as you see, my dear student, can you notice that the particles, the molecules of this marker, of this whiteboard, in a state of continuous motion? Can you notice this motion? Sure no. You can't notice that the particles or the molecules of ice are in a state of continuous motion. You can't notice that. Why? Because the motion is limited. Limited motion. And a liquid, intermediate. Intermediate, relatively. relatively high, not very high, okay? But in gas is freely. They move freely. The perfume spread in the whole room because molecules of gas have freely motion. They move freely. This is the first property of molecules. Number two, intermolecular spaces. As you see, my dear student, here there is spaces, intermolecular spaces, as you see. And here there is spaces. Here there are intermolecular spaces. But the intermolecular spaces here in solid, what? Narrow, small, very small. In liquid, intermediate, medium. And in gas, very wide, very wide. This is number two. Number three, intermolecular forces. In solid, as you see, if I want to drop this part, it will fall together. But if I have some drops of water, I can spill some of water and the remain will be in the cup. Because the intermolecular forces between solid molecules are very strong. Liquid, intermediate, medium. Not very strong, not very weak. And in gas, intermolecular forces, very weak. So, the gas spreads all over the places. Now, solids have limited motion of molecules, have very small intermolecular spaces, have very strong intermolecular forces, have definite volume and definite shape. Definite volume means that its volume, the volume of solid, doesn't change, doesn't increase, doesn't decrease according to the container, and so the shape. Liquids, these are the molecules of liquid, have intermediate motion of molecules, have a relatively large or intermediate intermolecular spaces, relatively large, that means intermediate. Have relatively weak, also intermediate, intermolecular forces, have definite volume but indefinite shape. Indefinite shape means that the liquid takes the shape of its container. It changes its shape according to the shape of container. If you put some water in a plate and put it in the freezer, when it be ice, you will notice that its shape as the shape of plate. And if you change the container of water, the shape of water changes. Gaseous state, as you see, this is the motion, very high motion, has unlimited motion of molecules, has very large intermolecular spaces, and has very weak intermolecular forces, and also has indefinite volume and indefinite shape. But now, as you see, my dear student, these are the molecules of solid. These are the molecules of liquid. These are the molecules of gas. How can we change the molecules of solid and change solid into gas, into liquid? Just to separate these molecules, to increase intermolecular spaces. How? Just by heat. So by heat we can change solid into liquid. And this process means melting. It's called melting process. So what's meant by melting process? It is change of matter from solid state into liquid state by heating. Okay. Last point. What's meant by Vaporization, it means it is the change of matter from the liquid state to the gaseous state by heating. And by this point, we reached the end of our episode today. I have now to say goodbye and see you next week.